We are going to talk about another exponent rule. This one's called raising terms with exponents to a power. So we're going to write in our journal the title, and then we are going to go through a sequence of problems to come up with some kind of rule that we can do when we have a term like this, like m to the a raised to the b power. So we need to discuss what that means. So I am going to write, this is slide 16, I believe. First problem is 3 times 3 to the second power. So what does order of operations tell us to do first? Why?
Because it's in the parentheses.
Remember, yeah, because it's in the parentheses. So it's in the parentheses. So see if we can simplify what's in the parentheses first. Can we on this one? Yeah. So this equals 9 squared. And now we can do the exponents. What is 9 squared?
81.
81. Okay, let's do another one. Let's do 3 squared times 3 squared. What do we do on this one? Exponents, what do I do with those exponents? Add the exponents, okay, and what does that come up with? 3 to the 4th. Okay. What is 3 to the 4th? Yeah, it's 81. 3 raised to the 4th power. Yeah, it's 81. How are these the same? Inside you have 3 times 3. Outside you have the squared. This one you have a 3 squared times a 3 squared. You see maybe there's a shortcut here? Okay, possibly. All right, let's go to the next one. 2 to the 3rd squared. So parentheses first. So what is 2 to the 3rd power? 8, yep. Let's keep it in parentheses. Squared. And then what is 8 squared? 64. Right. Because what does this, let's do it like this. 2 to the 3rd squared. Let's think about it in a different way. Let's square it first. So squared means repeated multiplication. So I'm going to multiply 2 to the 3rd times 2 to the 3rd, right? Because 2 to the 3rd squared, just like if I say a squared, that means a times a. Now, whenever I have 2 to the 3rd square, 2 to the 3rd times 2 to the 3rd, what is my power? 6. So 2 to the 6. Shouldn't this equal the same thing? So let's check and see if it does. 2 raised to the 6th power. Yeah, it's 64. So what I'm seeing here is that 3 times 3 squared is equal to 3 squared times 3 squared, right? And then this 2 to the 3rd is equal to, oh, that's squared, 2 to the 6th. And this one was equal to 3 to the 4th. Do you see any kind of shortcut that we could do? Especially if there's a variable inside and we can't actually do to the 3rd power. What do you see? that could be the rule. How can you go from a third that's squared to a 6? What would you do with those exponents? Yeah, they're right beside each other. One has a base, the other one's outside a parenthesis. So possibly multiply. But whenever you have like bases, two bases that are the same, you add, right? Okay, so let's do another one. A squared to the 6th power. Let's expand this out. There's nothing I can do with that a squared. So what I'm going to do before we check and see if this is the right rule, let's go ahead and expand this out. So how many times would I write a squared?
Twice.
I'd write a and a to get a squared.
Mhm.
But how many times would I write it if this term is being raised to the 6th power? 6 times. So a squared times a squared times a squared times a squared times a squared. So 1, 2, 3, 4, 5, 6. So there are 6. So how many? What is the exponent now, is what I should say. 2? Because we add these, right?
Mhm.
What would that come out to be? To the 12th power. So I could have used the multiplication rule. When it's raised, when you have a term with a power or with an exponent and it's raised to a power, you will multiply these two guys, these two exponents, a to the 12th. So see how these are the same? Okay, let's do 4 squared to the 3rd power. So we could do 4 squared, 4 squared, 4 squared. So that is 3 times. So what is the exponent of 4?
6.
6. So I could have just done 2 times the 3, 4 to the 2 times the 3, which gives us 4 squared. To the 6, sorry. I said the wrong thing. Okay, number 7, 4 to the 3rd to the power of a. What do we do with the exponents? We have one base. We have parentheses around one of them. The one on the outside is going to be multiplied by the one on the inside. We keep our same base. So to the 3a. Okay, let's do another one. 3 to the a squared cubed. We've only been dealing with whenever we have one variable. Now we have a constant and we have a variable. How do you think it's going to be affected? You know what a lot of people want to say? 3a to the 6. But that is not right. What is wrong with 3a to the 6 as being our answer? What do we know about this whole thing? Huh? It's all being raised to the third power. So what this means is 3a squared, 3a squared, 3a squared. So it's not 3. It's 3, 1, 2, 3 times being multiplied. And it's a squared, 1, 2, 3 times being multiplied. So then what would it be? 3 times 3 times 3. 27, yeah. And then a squared, a squared, a squared. A to the 6. So what should have happened is instead of, we don't have to expand it out. That's just helpful to see how it works. But what you would do if there's an exponent on the outside of a term, you take that exponent to everything inside. It's kind of like the distribution rule, right? We use that with parentheses and numbers on the outside, and we distribute the multiplication. Well, it's like we're distributing the exponent here. So what's the exponent right now on 3? No, the exponent. 1. So I multiply 1 times 3, which would be just 3. So 3 to the third. And then a, 2 times 3 is to the 6th power. Then you're able to do 3 to the third. That means 3 times 3 times 3, which is the 27a to the 6. One more. Parentheses 2ab to the third raised to the 5th. So 2ab cubed is being multiplied to itself 5 times. But let's use the rule. What would happen to the constant of 2? Yeah, it'd be raised to the 5th power. Because that's a 1 right now, so 1 times 5. What about the a? Right now it's 1, so what's the a power? And then b, what's the b power? 15. And then we go ahead and do 2 to the 5th. Is it? Yeah, because what was 2 to the 6 was 64, so half of that is 32. All right, that's our last example. Let's write the rule down at the bottom. This is called the power rule. So this is when raising terms with exponents to a power, comma, multiply the exponents. When raising terms with exponents to a power, multiply the exponents. So the rule would look like this. M to the a raised to the b would be m to the a times b. Okay, your assignment is going to be called Scenarios and Function Values. So I'll pass that out. Make sure you complete that. Make sure you also complete that EOC review. It's all due on Monday.